So looking at this problem, we're going to answer these questions. In a big vacuum chamber, a ball is thrown with an initial velocity of 20.0 meters per second at an angle of 75.0 degrees above the horizontal from a height of 3.00 meters above the floor. What is the initial velocity of the ball? Okay, initial vertical velocity. Okay, so since velocity is a vector, it's at 20 meters per second at an angle of 75 degrees above the horizontal. We need to find its vertical component. Okay, so its vertical component would be given by this equation right here. So that would be not y, but rather velocity initial. Okay, velocity initial in the y direction is going to equal r, which is the magnitude, which is 20.0 meters per second times sine of the angle, which is 75 degrees. Okay, and we just calculate that. That would be 20 times sine of 75. 19.3. So that's 19.3 meters per second. And of course, this would be vertical. Because it's positive, this will be up. What is the initial horizontal velocity of the ball? Well, horizontally, we have this equation. Okay, so I'm going to write it here. It's not x, but rather the horizontal velocity. Velocity in x initial. And that is magnitude, which is 20.0 meters per second, times cosine of 75 degrees. Now is the degree sign over here. Okay, which in this case, that would be 5.18. 5.18 meters per second. In this case, we don't know if it's to the right or to the left, but it is forward. Okay, when the ball hits the ground, what is its horizontal velocity? Now, because in this case, what we have is a projectile motion. A projectile, the ball is a projectile. It only has acceleration in the vertical direction. In the horizontal direction, it has no acceleration, which means the horizontal velocity is constant, which means that the velocity in x, now let me put that in black, the velocity in x is equal to the initial velocity in x because it doesn't change, which is 5.18 meters per second. Okay. What is the height of the ball above the ground 1 second after it was thrown? Okay. Now, because we're talking height, we're only talking about vertical. In vertically, this ball is in free fall. which means there is a constant acceleration, which is the one caused by the gravity on Earth, which is 9.80 meters per second square down. So here what we have is we know the time, we have the initial velocity vertical, we have the initial position starts 3 meters above the ground, so we can calculate the height of the ball above the ground, and we're going to use this equation. Let me copy it. So our initial velocity will be 19.3 meters per second, and that is times the time, which is 1.00 seconds. That's instead of delta t, plus 1/2 the acceleration. Okay, now the acceleration, as we said, is the one due to gravity, but it's down. So I have to type it with a negative sign. Minus 9.80 meters per second square times the elapsed time, the time that passes, which is 1.00 seconds squared. Okay, make sure when you simplify that you do take care of order of operations. And here what we have is, let's see, 19.3 times 1 plus negative 1/2 times 9.80 times 1 square, and that is 14.4, and that would be meters. So the ball is at a height of 14.4 meters above the ground 1 second after it was thrown. What is the horizontal displacement 1 second after it was thrown? Okay, horizontally, we know that it has constant velocity. This is it. So the average velocity is the velocity throughout. So what we have is this equation. Okay, our constant velocity is, not that, 5.18 meters per second times 1.00 seconds, which that multiplication is easy, 5.18 meters. In what direction? Forward. As I mentioned before, we don't know if this is to the left or to the right. At what time after it was thrown does the ball reach its maximum height? So it's at a maximum height when it stops going up and it starts going down. So its vertical velocity at the maximum height changes from being positive to negative. So at that moment, it's 0. So at what time, how many seconds have passed? Basically, I want to know that the vertical velocity is 0. So I'm going to use this equation. Okay, the final vertical velocity, make it 0. So I'm going to put it here, and I'm going to say the final vertical velocity, which is 0 meters per second, is going to equal the initial vertical velocity in the initial. So that would be, we calculated as this problem, 19.3 meters per second. I missed space here. plus the acceleration, which we already discussed, it's going down, so it's negative 9.80. I'll put minus 9.80 meters per second square times time. So, and we know that the time is 1.00 seconds. Okay. No, it's not 1.0 seconds. It's the question, how much time has passed? Ah, silly me. Okay, I was reading the other problem. So we need to solve for delta t, for the change in time. So what we have here is that the change in time, and I'm going to copy it. It's going to equal, let's see, we're going to subtract the negative 19.3 meters per second, and then we're going to divide by negative. So that would be let's see, a quotient of negative 19.3 meters per second over negative 9.80 meters per second, square. And that is equal to positive 1.97. 1.97 seconds. Notice the units. Here we have meters per second, and here we have meters per second. So when simplifying, we just get seconds. So almost 2 seconds after, it'll reach the maximum height. And what is magnitude of its displacement at that point? Now, this is a tricky question because its displacement is both up and forward. So we need to calculate both of them, up and forward. Fortunately, we do know the time. Okay, so to calculate it up, we have similar equation to what we used here, but changing, instead of 1 second, we're going to have 1.97 seconds. Okay, I'm going to just grab this, and I'm going to change the 1 second for 1.97 and the 1 second for 1.97. And calculating that using the handy dandy calculator, we get I get 19.00, so 19.0 meters. Nice. Now this is not the answer to the question. This is only the, you know what? This should be the vertical displacement. This should be the vertical displacement. This is only the vertical displacement. The horizontal displacement is actually easier. I'm going to copy it from here. The horizontal displacement is, we just change the time because horizontally it's moving with constant velocity, which is 5.18 meters per second. I just need to multiply times the time, which is 1.97 seconds. And calculating that, we get 10.2046. So that would be 10.2 meters. So it's going to move 19 meters up and 10.2 meters forward. So the magnitude of the displacement, we have the formula right here. Okay, so yeah, you know what? Let me copy it. Yay. And should I put it as an R or a D for displacement? I'm gonna leave it as an R. My delta X is 10.2 meters. I'm gonna square that, and then I'm gonna add it to the square of the vertical displacement, which is 19.0 meters. Square that again, and then take the square root, and that is, let's see, this 21.56. Since we have 3 significant digits, it's 21.6 meters. And